Completing the square, the first thing you want to make sure of, well, one of the first things, is that the leading coefficient's equal to 1. All right? I don't want a 3x squared. I want a 1x squared. So my first move to make that happen would be divide everything by 3. Even if it means you're creating fractions. All right? We got to live with the fractions with this. Right? I was going to say there's nothing wrong with having a fraction there. Yeah, there's technically nothing wrong with it. It doesn't mean you want it. It doesn't mean it's desirable. But it's acceptable. All right? So you get x squared minus 2x minus 1/3 equal to 0. All right? In completing the square, we have really two first steps. Step 1 and 1a. Because you could do them technically interchangeably. You divide to create that leading coefficient of 1, but you also need to get rid of the c value. So whether you do the c value thing first or the coefficient first, that's up to you. I tend to take care of the a value first because I worry that I'll forget. So 1/3 gets added to both sides. All right, so it gets canceled here. You'll have x squared minus 2x, leave a space to complete the square, and you're going to get 1/3. All right, this is the kind of process that we always did the side work for. We took the b value, we cut it in half and squared it. So that's what I'm going to do here. A little bit of organization goes a long way. Some of us, whether we're there or not, we'll get to a point where we can do a lot of this in our heads. But until you get there, you need to have some kind of structure in order to make it at least legible. Right? If it's all over the place, it's kind of hard to tell what the thought process was. All right, so the side work is b over 2 squared. All right, the b value here is -2. So -2 cut in half and squared. -2 cut in half is -1. -1 squared is +1. So that's what's getting plugged into the gap. And that's what's getting added to the right-hand side. All right. We plug it into the gap to complete the perfect square trinomial. We add it to the right side because we added it to the left side. Now we have a perfect square trinomial. The factoring technique is to take the square root of the first term. That goes here. Square root of the last term. That goes here. Carry down the sign of the middle term. So x and 1. The right-hand side simplifies. Whether you do it in your head or in a calculator, it's going to simplify down to 4/3. All right. So, and again, if you're using a TI, the quickest, easiest way, I think, the way that involves the least number of steps, would be alpha y equals n over d. All right, that allows you to type in a fraction. It's the math print function. So put in the 1, put in the 3, hit the right arrow to get out of there, +1, and hit enter. And not only will it give you the fraction, but it'll give it to you in simplest form. And it'll give it to you in the form that we want, as an improper fraction, or a proper fraction, but it won't give it to you as a mixed number, which is really good. All right, so again, that's alpha y equals n over d. All right. I'll actually make a note of that here. Actually, I forget how that looks. Yeah, it's n/d. That's what I thought. This is the TI. All right, so we have our simplified fraction. Now, for 1/3 plus 1, maybe you don't need a calculator, but there's definitely ones on this page where the result of a computation is like 75 over 9, right? So you might want it for that. So I'm going to take the square root of both sides. The left-hand side, remember the radical and the power of 2 cancel each other away. Opposite operations. On the right-hand side, we chose to take the square root. So we introduced a plus or minus. All right. So then I can add the 1 to both sides. And I'll have an answer. It's just a question of how my answer needs to be represented. Let me just fix that radical. It made it a little small. It's going to look like it's not part of the fraction's not part of the entire radical. Ah, geez, Louise. I don't even know who Louise is. Yeah, I'm sure she's nice. So 1 plus or minus the square root of the fraction 4 over 3, but that's not one of the choices. So it's like, oh, we must have done something wrong. Well, not necessarily. Right? This is just one form of the correct answer. We need, because we have choices, we need to get it to one of their forms. Right? And that's, when you have a multiple choice question on an assessment, that could be how it plays out. If a question said in simplest form, well, if you have a radical containing an entire fraction, that's not the simplest form. Remember, we need to have the radical in only one part of the fraction to be considered simple. All right, so I'll break up this radical top over radical bottom. So 1 plus or minus, well, the square root of 4, that's perfect. That's 2 over radical 3. All right, so that's simple, but it still doesn't match one of their choices. If you look at all their choices, you'll see every one of them has a rational denominator. All right, so we need to have a rational denominator. I have a rational numerator here. So let me rationalize. So I'm going to multiply top and bottom by radical 3. So that's going to give me 1 plus or minus 2 rad 3 over 3. It's crazy because really, if you think about any other kind of completing the square, we would be done after really this step. The reason why this is the longest one ever is because you got to do all this other side work to get it to match one of their choices. So let's say it's a multiple choice question on a test. Once you get to this answer, if you don't want to do this other work, take this answer, put it in a calculator, get a decimal form. Take their answers, put it in a calculator, get a decimal form, and see which ones match up. Maybe it's a time saver.
There's that answer isn't on this side.
We got one more step to go. Yeah. All right, so you'll notice that all of their choices are combined into a single fraction. So we'll do that too. All right, so in order to do that, we need a common denominator. So I'm going to take this 1, which could also be thought of as 1 over 1, and give it a common denominator with the other fraction. So multiply top and bottom by 3. So 3 over 3 plus or minus 2 rad 3 over 3. And when you put those two fractions together, you get 3 plus or minus 2 rad 3 over 3. And that should be one of the choices. I think like the second from the top, maybe the third. Third. Choice O, for those keeping score at home. All right, so fairly lengthy problem. They're not all this lengthy. All right, so don't get